All right, here is the key for a net from the Bangles, which is worth 1/10 of a point. Walk like an Egyptian. So this is, I think, a pretty easy question. We've got 6 potentials, 6 wave functions, and you're supposed to line them up. And so let's start by identifying the key features of each of the potentials, most notably the quantum number. The first one, A, has n equals 3. It's the third line, so there've got to be 2 nodes. The second one, the V, has n equals 2, so there has to be 1 node. The third one, C, has n equals 2 as well, so there has to be a node. The little bottle over there, D, is totally impossible. You can't have a potential that comes back in on itself like that. E, the kind of a half of V, has n equals 1, so there's not going to be any nodes there. It's a ground state. And finally, the half well F has n equals 2, so there's going to be 1 node. So nodes are one of the characteristic features we have to look for in these wave functions. And then the second thing is we have either hard walls or soft walls. They're either going straight up or not. So let's see, A has got hard walls, so the wave function has got to go to a hard 0 on either side. B has soft walls on either side, so it's going to go softly towards 0 on either side. C has hard walls again, so we're going to go hard to 0 on either side. D is impossible. E has 1 hard wall and 1 soft wall, a hard on the left, soft on the right. Same is true with F. There's a hard on the left, soft on the right. So those are the essential features for the solutions. So now let's go over and identify the connections. So the first one is going to be wave number 4, has got those 2 nodes there and goes hard on either side. Wave number 6 is going to be associated with B because it's soft on either side and has 1 node. Now wave number 5 is going to be associated with, wave function number 5 is going to be associated with C because it has 1 node and it's hard to 0 on either side. D is impossible, and wave function 3 is impossible. It's discontinuous. And let's see, E is our half V, and that's going to be associated with wave function 1 because there's no nodes in 1, and it goes hard to the 0 on the left-hand side, soft on the right. And finally, a wave function 2 has 1 node, and it goes also hard to 0 on the left, soft on the right. So those are the elements there, and we just write it on down. So A is going to be number 4, and again, it's got 2 nodes, and it's hard on either side. B is number 6. It's got 1 node, and it's soft to 0 on both sides. C, number 5, has 1 node, and it's hard to 0. It's also less curvy in the middle, so that would be unacceptable. There are really 3 identifying features there. You see it gets sort of straight in the middle because the potential comes up in that kind of half double well situation there. And then let's see, D, that's number 3, and it's discontinuous. That's one reason. Also, it integrates to infinity if you square it, so the probability can't be found. It's not normalizable, and you need 2 reasons for each of these things, so you got to get both of those. E is going to be number 1. It's got no nodes, and it goes soft on the right-hand side. Finally, number 2 goes to F with 1 node and soft on the right-hand side. So for the points assignments, there are 6 total wave functions, A through F, 30 points, so they're going to be 5 points each. And for those 5 points, 1 point is for simply getting the assignment, and then each of the 2 reasons is going to be worth 2 points for each of the questions. So it's a pretty simple point assignment there.